All right, we're back. We're on page 2 of note 17 of Calc C, talking about polar coordinates. Kind of a big deal. It's a different way of looking at the world. You actually end up using them quite a bit when you get to Calc 3, especially when you're doing, I mean, it doesn't really matter. When you're doing double integrals, a lot of them end up being easier to do in polar coordinates. And you'll find like it's actually straight up easier. Like you think when you're learning this stuff for the first time, you get to polar and you're just like, everything is so much harder. But then like later on, you find out like, oh, thank God, we're going to be able to do it in polar. So you get used to it. It takes a little time, a little experience, but I think you'll end up liking it. So most of our equations, like when you're going to graph something, you're going to have r is equal to f of theta, because remember, r is the dependent variable. And think y equals f of x. X is the independent, y is the dependent. Y equals f of x. Here we have r, the dependent, equals f, some function of theta, in most cases. Sometimes, because polar is just straight up different, sometimes you can only solve for like r squared or something like that. We're not going to run into too many of those. And even when we do, it's not going to be an issue. So don't worry about that. Let's see if we can convert these. These are straight conversions. Shouldn't be that bad. Here, if you think about it, r equals 5, if we graph it, like you're at 5 and you have to always be 5 away, it's just a circle. X squared plus y squared equals, it has a radius of 5, so 5 squared, or 25. And that's it. That's all you need to do. Much easier to work with polar if you already know the answer, which is like the most backward way of thinking about something. But if you know the answer, you don't have to do the work. If you don't know the answer, there's like all kinds of paths you can try to take. So if I start with r is 5, what I think I should probably do is square both sides, get r squared is 25. And then I know, because one of the formulas I'm supposed to know is that x squared plus y squared equals r squared. X squared plus y squared is 25. So knowing the answer tells you basically like how to get to the answer. It's weird, but that's why practice helps. Here, if I were doing this, I would think cosecant goes with sine, sine goes with y, this is y equals 1. Let's do the work. So I mean, we're going to get y equals 1. So r is equal to 1 over sine. And that means that r sine equals 1. My music's like a little loud. I'll turn that down just in case it was picking it up. R sine is equal to y, so y equals 1. Another one, you just got to know the formulas. If it was r equals secant, I would have said secant goes with cosine, cosine goes with x, it's x equals 1. And then you can go back and do the work, but like knowing the answer ahead of time is super helpful. So make sure you do. This one, all right, so I find people have the most trouble with this. And it kind of makes sense to me that you would, because like all that you have is the independent variable. Like, what are you going to do? Well, if you have a theta and you're not sure what to do, like put it in a trig function, right? And what trig function would be the most useful? We know that tan of theta is y over x. So if I do the tangent of theta, that should be equal to, and then I'm going to stop switching this because it's annoying, the tangent of pi over 6. And there you go. All right, now tangent is y over x. Nope, wrong color. It's not that it's wrong, but tangent y over x. The tangent of pi over 6 is root 3 over 3. So finally, y is root 3 over 3 x. That's it. Now, I was able to do this because I already knew the answer. Like, I know when I see theta. Another thing that I definitely know is in rectangular, that was supposed to become like a line. There we go. And then this, please. Nope. Here we go. Okay. Theta equals pi over 6 is just a line that makes an angle of pi over 6 with the x-axis. So if I were to graph it, that's probably not right, but so this is going to be pi over 6. It's obviously a line going through the origin. Just figure out how it's going to be a line going through the origin. So tangent can help you out there. All right, let's take a look at the next one. This one I think you are, like right now, with the least amount of practice, the least likely to remember. But I remember it. I remember that this is a circle. Now, I know it's a circle, and that's extremely helpful. I know that cosine goes with x, so it's a circle that's centered on the x-axis, and I know it's the diameter times cosine. So r equals diameter cosine is going to be a circle that's centered on the x-axis with the given diameter. So, and it's also a directed diameter. So if it was -10, it would be on the negative x-axis. If it was positive sine, it would be on the positive y-axis. If it's negative sine, it's on the negative y-axis. Watch the videos. There's lots of videos of that. There's me doing the notes, but there's also additional videos just explaining parametrics in circles, I think. Recommend that. I'm trying to make it. Look at that. Woo! That's because the iPad took over and did the whole thing. So this is a circle that's centered at 5, 0. So it's going to be x minus 5 squared plus y minus 0 squared equals, as a radius of 5, so 25. And you're done. Knowing that is so helpful. Other things that are helpful, knowing that this takes pi to trace out, which means you're here at 0, then you're here at pi over 2, then you're here at, I don't know, 3 pi over 4, I guess, and then you're here at pi. It only takes pi to trace out the entire thing. That's going to be super relevant when we try to find the area of this thing using calculus. Finding the area of a circle with a radius of 5 is not that bad, but using calculus, we want to be careful not to double count. And so, big deal knowing that. So if you wanted to do the work, I don't really recommend it on this, but you can. So you would have this, and then I'm going to multiply both sides by r. So I'm not squaring, I'm multiplying by r. And the reason I'm doing that is what I want is, I want to create this r cosine, right? That's just x. So now I have x squared plus y squared equals 10x. And then I can bring that over. Plus y squared equals 0. I can complete the square, right? Which is divide by 2 is -5. Square it, that's 25. Add that to both sides. And this is our perfect square trinomial. So this is x minus 5 squared plus y squared, 25. Same place, we end up in the same place, but which of those was easier? I think it was definitely easier to look at the equation and be like, I know what this graph looks like, graph it, write the equation. So at the bottom of this page, I have a summary of the things you should just know. All of these are in note 16 of analysis, so hopefully you have done that and you are used to it, and this is very much review. But r equals k is a circle. It takes 2 pi radians to trace out. That's a big deal, 2 pi if it's r equals k. K secant is going to be x equals k. K cosecant is going to be y equals k. Theta equals k is a line through the origin. That's a big deal. And you just get y equals the tan of k times x. Then these are a big deal, right? They're circles that are tangent to the origin, centered on one of the coordinate axes. And if you know those, then converting them is going to be super fast. Also, just graphing them is super fast. And that's one of the things you want. Like these, that shouldn't be a stumbling block. All right, so this is all review. Hopefully you found it helpful, and I will be back in the next video to do more of it. So I will see you there.